Okay, very good afternoon, all. Hope you are all fine, and welcome to my channel on simple circuit design and realization. This is the today's topic. Why we are proposing this topic means that is somewhat different. So, basically, the aim of this lecture is to promote how to realize some simple circuits using the online available tools so that the learning become very simple and it should be like a lifelong learning process. I always suggest to the viewers to realize any circuit what you are studying or designing. For example, students, if they are going with some simple circuit means what you can do is just you can read the basics, formulas and whatever you want. And then don't stop with theoretical analysis, go with practical analysis. Then that will help you to solve certain things which are not you cannot able to imagine. That is, you can able to develop your own circuit and you can realize what is your need. If I need something means based on the necessity, I can design my own circuit. This is the main aim of this lecture, how to realize any simple circuit and how to make the things practically realizable using some already available online tools. So that is the main motto of this lecture. So participants or aspirants who are watching this lecture, my sincere my sincere query or sincere obligation to you is, whenever I am doing something, whenever I realizing something, you can also work parallelly with me so that you can gain some stuffs from me directly. Since if you realize something along with me means I can make the thing something simple. So how to realize, what are the simple tricks and what are the simple things that you don't know, that I can introduce in this lecture. So basically in this lecture, I am going to introduce a online tool called LT Spice. That is a very, very simple tool. You can able to realize any circuit starting from low level to high level in a very simple manner. And you can able to realize some things which are beyond our imagination that we are going to tell in a detailed manner in this video. So in the next 50 or 45 minutes, we are going to start with some simple circuits, and I am going to tell in a step-by-step manner how to design that circuit in LT Spice and what is the theoretical analysis result and how we are going to realize that in a practical manner. In that aspect, I am going to take you through this lecture series. So basically in the upcoming slides also, I am going to design certain circuits so that it will become a revamp for you to understand the necessity of circuit design and realization. Let's go into this lecture series and watch what we are going to discuss now. So basically I am going to take an inverting amplifier. You see, usually while teaching integrated circuits, everyone will start with the basics like when ICs are manufactured, when it was invented, what is the revolution, like that, many things, many steps they will explain. But apart from that, what I am thinking is directly start from the topic and make you to realize how this circuits will work. That is the main aim of this lecture. So basically, what is an inverting amplifier? Inverting amplifier is a very simple electronic circuit used for amplification. What is meant by amplification? Amplification is nothing but increasing the gain of the signal without disturbing its original characteristics. Suppose I am speaking, if my voice is given to the amplifier, means what it will do, it don't disturb my voice characters, but it can able to amplify my voice so that it can able to reach 1,000 peoples. This my voice is audible only to certain extent, maximum of 60 capacity or 100 peoples. Or if I am giving to able to give it to a amplifier means you can able to address to a big crowd. So that is the main aim of the amplifier. Here we are going to discuss about the inverting amplifier. I am not going into much theoretical, since theoretical you can study from anywhere in this world. Since everything is in your hands now, internet is available, everything is available, you can able to learn by yourself. But what is the major thing is how you can realize what is the meaning of the graph. that are all missing in today's scenario, today learning scenario, that I am going to address in this video. So let us think over it. So I am going to deal something about this inverting amplifier. What is meant by inverting amplifier means usually operational amplifier can be realized in the form of two forms of gain. One is by means of open loop gain, and another one you can call it as closed loop gain. So that is the main idea. So what I am telling is, so you can see here, this open loop gain, that is AOL, is nothing but the operational amplifier is said to be operated in the open-ended mode. What is meant by open-ended mode means without feedback. Without feedback, the operational amplifier will set to go. That means what happened in the open loop gain, what is the main disadvantage is the open loop gain operational amplifier is used for some other purpose. It is not unpurposeful, it is purposeful, but we are going to, when we are going to use that, that is the matter we have to understand. So open loop gain of an operational amplifier is generally very high. It is infinite. We cannot even imagine. That is, they are mentioning that as 120 decibels. If you realize that means you can able to understand. Okay, or more. Even research are also going on open loop gain now also. So what is the main disadvantage is due to this high, very high gain, this operational amplifier is nothing but like a ghost. It is uncontrollable. Okay, that is, we cannot able to control that operation. When you give any input voltage to it, immediately it will go to into saturation. We cannot able to control even for a very simple application. For example, I am giving 5 volts. I want 10 volts means we cannot get that. 5 volt means directly it switched to even saturation level. That what is saturation, how you can realize. If I am telling all these things in theory means it looks like a boring concept. Whatever I am telling, if you realize by using one simple tool means that will be stored in your it will be stored in your knowledge. It is asset for your knowledge so that you cannot even forget at the time of anything like exams, interviews, anything. So that's why this main motto of the video is make the thing realizable always nowadays. Okay, so so what we are telling is this very high gain is no use. Actually, there is no use of it, since what is the only disadvantage is the amplifier become unstable, and we have it become very hard to control the operation of the amplifier. So unstable means we cannot tell when it will go, what happen, anything. It is not possible. So what we are doing is we are going to make the amplifier little bit stable so that it can able to fit some application according to our design. So if a shootable resistors, if you connect across the feedback in the feedback loop, if you connect certain resistor means what we can do is we can able to control the operation of the amplifier. If once the device is said to be controllable, then automatically which parameter is guaranteed? Its stability is guaranteed. Okay, that is called Nyquist criteria. We are studying many things in control systems. So how to control a system, in that the feedback systems form a major role. Here also we are going to teach you about this, how to make this amplifier as a perfect shootable component to control certain aspect of the input signals that we will see. So next one is what means let us consider this is as a basic circuit. I don't want to explain in a very detailed manner, since we are having stuffs to teach you about how what are all the things to be done and how to make everything to be realizable. In that manner we are planning. So this is the basic circuit. In this basic circuit, what happened, we are having why this is called as inverting amplifier. The input signal is given to negative terminal and the positive terminal is grounded, and you can see here one feedback resistance is connected here. This is called as closed loop operation of the operational amplifier, and this is called as a negative feedback. This is called as negative feedback. Okay, so if you take positive terminal and give back once again means that is positive feedback. Next we will discuss that. Okay, So when you consider this inverting amplifier, everyone will tell this is it will go here minus symbol, so output will come in the negative form. Concept over. But apart from this, what you have to understand from the technical point of view, what the expectation is, you have to understand that this input current will not go into this operational amplifier. This input current will not flow into this negative terminal. That means input current is what? Zero. We are assuming. That's why the arrow symbol you can see it is coming here. It is not going to this. This thing you have to realize. That is where this operational amplifier plays a vital role. Okay. So why this current is not going here means the operational amplifier generally have very high input impedance. So due to this input impedance, the current unable to overcome and flow into this negative terminal. So it takes the opposite path and pass through the RF side like this. So from here, what happened? This positive terminal is grounded, so you will get some minimum amount of current here also. So that will come here, and you can get in this end. So the feedback resistance, if you measure the current, means that is nothing but the difference of these two current. But ultimately, as here the terminal is grounded, automatically this current is set to be zero. So which current only will flow through the RF? This output current is set to be flow through the RF and come. That is the and flow to the ground. This is called as virtual earth or summing point or virtual ground concept. So here they are showing current, but ultimately due to this virtual ground concept, the IF become automatically zero. So ultimately, what is the current flow across RF? Not IF, it is only output current of the operational amplifier. This virtual earth is going to make to think about some important operations, what operational amplifier can be able to perform. So two rules you have to consider: no current flows into the input terminal, and differential input voltage is zero. Okay, these two differential input voltage become zero since V1 and V2 are zero. These two things are said to be zero due to virtual earth. So due to this concept is called as CMRR. Whenever the CMRR is very high, what are all the common signals available across V1 and V2 will got cancelled, and only the expected voltage will come here. So more the CMRR, high will be our output. This is the concept, working concept behind the operational amplifier. Now you can check this circuit here. Now the operational amplifier, I am just omitting this since the current is not flowing into the input terminal. Okay, so I am treating just a simple series circuit, RIN and RF connected in a series. So how the equation will come, you can check here. So V in minus V out divided by R in plus RF. This is general Kirchhoff's current law. You can V by R. So you can current incoming current, that stuffs you already know. So what I am doing is I is equal to what I am doing V in minus, you can see here V in minus V2 divided by R in, and V2 minus V out divided by RF, both are said to be equal. This is a node, so the incoming node and outgoing node are said to be what? Equal. That is what we are writing here. Kirchhoff's current law, right? I is equal to the summing current in a particular node. Sum of the current in a particular node will be equal to zero based on that. So after that, what we are doing, I is equal to V in by R in minus V2 by R in is equal to these things you can know. So here what we are doing, V in by R in is equal to what happened, that is the thing. This minus V2 by R in will come to this side, and we are taking these two things as common, and 1 by R in plus 1 by RF minus V2 divided by RF. This is the form. Or directly, if you are having additional, if you are able to understand, means sir, why unnecessarily these steps are coming? V2 is directly 0, so I can substitute V in minus 0 by R in, 0 minus V out by R in, or you can cross this here. So what I can get, RF divided by R in into RF divided by R in is equal to this V in, you can transfer this side. Okay, so what 0 minus V out divided by V in minus 0, this will come down. This will go up and this will come down. So automatically, what is the formula? V out divided by V in is equal to, you can transfer this minus here, minus R of divided by R. This is what we have to understand. While studying inverting amplifier, if you are remembering these all steps or not, you have to remember gain of the inverting amplifier will always equal to minus R of divided by RE. So if you want to calculate gain, this formula will serve you, minus RF by RE. If you want to calculate output voltage from a particular inverting amplifier, then what you have to do, V out is equal to minus RF by RIN into V in will be the ultimate formula. So closed loop gain is nothing but AV. That is nothing but what? Minus RF divided by RE. Okay. So next, instead of going into this, if you study this means that's all, the matter is closed. But what is the main aim is how to realize. That is, we have to think something. So the problem statement, I have written my problem statement by my own. So you can example for my signal transmission project, an amplifier with a gain of 10 is required. This is my statement, stakeholder statement, so that the signal can be phase inverted and transfer through common band without any overlap. So where the inverters are used means, if I want to transfer two signals in a common wire, that two signal can be overlaps due to same phase and frequency. If I want to send that without any overlap or any negative glitches or any noise glitches means, then it is recommended to invert the signal and you can send through the common band so that the transmission is successful. Once in the receiver part, you can just invert the another signal which is in the inverted mode, re-invert. That is, once again, if you do inversion means automatically that signal come in the original form. This is how we are. Also, some form of signal they don't want to generate the signal in the actual phase due to some criteria. They will invert the signal, send and re-invert. That is also, it depends on application to application. So here we are considering how to make the things realizable. For that, I am just generating this problem statement by my own. And here, what are the data I am identifying? Gain is equal to 10. The signal is to be inverted. The signal here, they have given phase inverted. So signal is to be phase inverted. So inverting amplifier is to be designed with a gain of 10. This is the ultimate problem statement. So next what I am doing is design procedure. They have given already gain is equal to 10. So what is the formula? Already we have discussed. Gain is equal to minus RF divided by RI into VI. So if I substitute gain is equal to 10 means I will get minus RF divided by 1K into 5 volts. 5 volts is my input voltage. This is as per the user wish. They know what is the input voltage available. Here I am for analysis, I am taking 5 volt. So RI is equal to 1K and RF is equal to 10K. This is with these two steps, I can able to design a circuit. Okay, this is non-inverting amplifier that I will come into next part, or otherwise I will tell here the same thing, but what is the thing is positive feedback, but the gain circuit will be what? 1 plus RF divided by R2. Why means due to voltage divider rule. This gain you have to remember for realizing the circuit. So now we will go to the realization part. How to realize these two circuits by using LT-Spice. So LT-Spice is a open tool available for download. Okay, anyone can download this LT-Spice. This is a very simple circuit for analyzing anything. So how I am going to realize, that is very important. So you can see here what I am just doing so that you can build your own circuit. Now I am just deleting everything for your understanding of stuffs. Okay. So first I will tell you the glimpse and then I will make you to realize. Okay. Okay. So why I am removing all the things is, those who don't know, I will walk you in a step-by-step manner. Then it will be really good. Okay, so minimum criteria I am reducing. So here also I am going to realize the entire circuits, inverting and non-inverting in a single screen, so that you can able to realize what is the real operation of the circuit. How to remove means just press delete button, the scissor symbol will come. If you click over the line means the screen becomes empty. Otherwise you can open the new draft. So this is the entire workspace of a LT Spice. If you load this means you will get the screen like this. If you go new means you can click new schematic and this screen will be visible to you. Okay, this is the first process for your design. Next you have to click this component library. If you click component library means here if you type op-amp means so many symbols will come, but best practice is if you type op-amp, here also you can see op-amp 07, right? Op-amp 07. So if you want to see its information means you can go ahead and check the websites so that you can able to see it. The data sheets will come so that you can see what is its operational voltage, what voltage you have to give, what is the biasing voltage, everything you want means you can see here. Number of op-amps are available. You can check this precision operational amplifier, like that many things are available. You can check it in the website. So data sheet you can see means it will give you more steps. So due to lapse of time, I am just calling the best version, that is LT100. If you give means this is one of the best form of low level operational amplifier. This is also called as precision operational amplifier. You can see here it is used mainly to work with very small voltage, very light level voltage. Operational amplifier means this is also precision amplifier only. You can try out in your own manner, anything you can use. Okay, so LT100 I will give you. So if you place means it will come like this. It is duplicate. Number of times you can duplicate. It is very simple and user friendly version. So students can design the circuit in just a fraction of seconds. Okay. So after this, what you have to do, what is our requirements? Actually, operational amplifier will look how it will look. That is our aim. So your operational amplifier inverting circuit will look like this. One is your input resistance, another one is your feedback resistance, and this main terminal should be grounded. These are all the steps. So what I am doing is I am going to take my requirements. What are the requirements? Resistor I need. While taking the resistor itself, the resistor will come in a vertical fashion. If you press Ctrl R, this will be rotated. So you keep as like this. Okay, it will be better now. So you can keep this in the feedback path also, one resistor required. So I am keeping here. After that, if you want to put compensation resistor means you can add, but as of now I am not considering, so I am keeping it. And after that I need voltage sources for giving inputs and bias. Usually operational amplifier will require bias for its operation, so you need to give the bias also and grounds also. So first we will give the biasing circuits. So here I require one bias, and for this positive terminal one bias, negative terminal one bias. Okay. And then for ground points, I have taken this one. This here one ground is required. For positive terminal is to be grounded, and these 2 points to be commonly grounded. This is very important. You have to know all these things. And how I am going to connect, you can check here. So first I am taking this wire, and you have to see a scale is coming. Just connect this and this. Click here like this. And from here, this plus mark, this scale will cross wire will come. You can stop at anywhere and you can turn like anything. Just it will connect automatically. Okay. And after that, you can stop from here and you can go here, come here, and then connect with this point. Okay. Now the circuit is ready. Now what I am doing is from here, you can take one wire and connect it to the positive terminal. Okay. Now what I am doing is next you will try to connect all these points, but I am going to tell you one important information. Please listen. Okay, that is the main aim. This point you need, if you consider means the circuit design will become very simple and look very professional. So these things are direct connection. After doing this, if you want to see the circuit perfectly, means zoom to fit, so that you can see how we are connecting all these things. Then we need to connect this positive and negative to here and here. If you take wire and connect, means cross wires will come. Instead of that, what I am doing is I am right clicking the mouse. If I right click, means you will get a thing called label net. Okay, label net. So I am clicking that, and you can give the name VSS, that is positive bias, plus VCC we are calling. So in operational amplifier, we will call it as plus VCC. Okay, no issues, you can give. This VCC will come here. So you can just click, you can see a node here. Below VCC, you can see a small node that you place over this V2. Place over this V2 perfectly. If you place the view here, means it will become vertical like this. That means it is connected automatically. Some here also place here. So now these two points are connected, said to be connected without any cross wires. Then put these things once again, view and zoom to fit. Now you can see here. Now similarly in the negative stuff, you have to create another label net with minus VCC as a caption. For understanding, whatever you want you can create, right? So here I am pressing this minus VCC. Here also I am giving it as minus VCC. So these 2 points are connected. Okay. After doing this, what I am doing is, you can see this point and this point. Now this also I am giving a label nets. You can ask why. You can directly connect, means I am going to develop another circuit. For that it will be equal. So I am calling that as VI. I am calling it as VI. So I am connecting here and also connecting here. So these 2 points are connected. Now all your works over. Now what we are going to do is, this is inverting amplifier. First we will do the theoretical analysis. Okay. So here this voltage, how to define this voltage, DC voltage or AC voltage. If I want to develop, assign AC voltage, means you have to go into advanced button and then click this sine volts offset that you have to click, and here you can give 0, and this amplitude can be how many voltage we are giving. We are assuming in this PowerPoint, you can able to see that the design I have taken 5 volts as the input. So whatever I am giving, I am also giving 5 volt here. And the frequency is what? 50 hertz that I am giving. And then click OK. Okay, so that's it. So you can see sine wave, 0 offset, and 0 means it will start from the negative point, 0 perfect origin, that is called offset. And then any minus starting point also you can define, that you can study. This is frequency and this is the amplitude, plus 5 and minus 5. Okay, so here this end. Here DC value, this is not AC, biasing voltage only. So I am giving what here, 10 volts or 15 volts I can give, no issues, 15 volts. And here also I am having that same 15 volts. Okay. Now here one more thing is there. If you go into this, means you can see a sine wave, everything is defined, 50 volts, everything. So click OK as of, right? So this is the thing. Then we have to define this resistance value. That is very important. So if I want to change the name of this resistor as or input, you can change RI, that is input resistance, as per the diagram. And if I want to change, right click and change it whatever you want, RF. This is called realization. So what will be the output? Now you can tell here 5 volts I am giving. Feedback resistance and input resistance I have to define. Okay, so I am defining this as per the design 10 kilo ohm, and here this value will be 1 kilo. This is not the value, so 1 kilo ohm. So as per the thing, what should be the answer? Minus RF by RI into VI. So minus 10 divided by 1 into 5. So output voltage will be what? 10 into 5, 50 volts. Minus 50 should come. The question is whether minus 50 volt will come or not. As per theory, if you work out one problem means they will give the answer as minus 50 volts. Everyone are thinking that minus 50 volt will be given as the output. Everyone will think. This is theory. Now I am going to run this simulation. You can see here our expectation is what? Minus 10 divided by 1 into 5. So you have to get how much? Minus 50 volts. Now what I am doing is I am running this program. So you can stop time. You can keep it as 0.1. Okay. 0.1 or 0.01. If you give the stop time little very precise, the output waveform will look very perfect. Here, as per my requirement, I am giving the stop time as what? 0.1. Okay. Now you can see here something is coming. What you are seeing here? You can see here the output voltage is looking somewhat not. So here I will just to measure the voltage here. Okay, you can see here input voltage also I will keep this. Automatically this cursor will come, measuring probe, this is called. Well, after clicking this run button, if I plus means the measuring probe will come here. So you can see here what is happening here. You can see milliamps is coming, ignore that. Here I am giving the voltage. You can see this is 4.7. Some drop will be there usually. Okay, perfect 5 volt will not come due to high input impedance of the op amp. We are putting resistance and we are making to flow as per our, instead of going into saturation, we are preventing. So input voltage is approximately 4 point, peak voltage you can measure here 4.73, and lower also minus 4.73 will come if you measure means 4.73 or 4.8, minus 5 volts, everything is coming. But if you click the cursor exactly means what will be the voltage, you can see. So the voltage is approximately oscillating between plus 5 volt and minus 5 volt. But you can see here here you can see this square waveform. You can check here. This square waveform is clipping at minus 13.1 volt. What is our expectation? But we have to get minus 50 volt here, 50. But you are getting only minus 14 volts. Why? The main thing is here we are supplying biasing voltage how much? 15 volts only. So whatever voltage you are giving, whatever theory you are speaking, depending on the bias voltage, what is the maximum capacity, that only will be conducted, remaining thing will be clipped off. If I remove this input resistance and feedback resistance means it don't think about the input voltage, directly it will be go into saturation. So what is the purpose? Directly we can conduct in open loop mode. Why we are conducting directly, it is going and clipping means then we have to realize this is where the work should be done. So 10k and 1k means we don't get any inputs, that is 10 into 5, 50. So what, instead of that, what I am doing is I am going to change this as 1k. If I give 1k means what happened? This is called realization. You can change. Okay, 1k means what happened? Minus RF is 1k, RI is also 1k. So 2k also you can give. 2k means it will come 10. 1k means it has to give minus 5 volt as output. Okay, minus 1 divided by 1 into 5. So if I run this circuit means what happened? You can see here. Now, what is going on here? Input voltage is also 5 volt and output is voltage is also minus 5 volt. But what happened? These two things are phase shifted. This is positive in nature. This is negative in nature. Another one graph is for amps. Okay, don't consider this. Only see the VI. This current IV2 you no need to check. Okay, IV2 you no need to check. Don't see this. Only VN002. That is nothing but what this and inverted output is voltage node 2, and this main voltage is voltage node 1, V1. So that only you check voltage across this. It is showing already. This is I. Current is voltage 2. You no need to see this. Okay. If you see this means you will get confused. right? So what I am telling is here it is starting and it is going up to minus 5 volt, coming up to this is perfectly going, right? So in the output what you are getting, minus RF by RI into V input, that means minus 5 volt. Minus 5 volt means what we will get, it starts from minus 5. When it is positive peak voltage, it will be negative, that is inverted 180-degree phase shift. Again when it is negative, this will be positive. This is going to positive means original signal will be negative. Like that it will change. For better understanding what I am telling, one more thing we will do. Instead of this 1K, I am going to change it as 2K. Then it is realizable, right? 2K, then click OK. Now if you run this means, what you are getting now, you can check. Input voltage is oscillating between minus 5 and plus 5. But output voltage, how much it is going? Minus 10 volt. So why it is going to 10 volt? 2 divided by 1 into 5 minus 2 divided by 1 into 5. That means how much you will get? 2 into 5 minus symbol for inverting terminal. So you will get how much? Minus 10 volt to plus 10. Above 15, if anything is coming, means the output waveform will be what? Clipped off. Will be clipped off. That is called as saturation point. So this up to the biasing voltage only, operational amplifier can able to give faithful outputs. Above anything, if it is going beyond the biasing point, means operational amplifier will effectively work up to the biasing point, remaining everything will be clipped off. That is called saturation. Operational amplifier will enter into the saturation. Right. Now, this is okay. Now you can able to understand what is meant by a inverting amplifier. Right. Now I am going to show you how to design a non-inverting amplifier in a same thing, but what is the only difference is 1 plus 2, 1 plus or F divided by Ri. So 2 times you will get. So 5, here I am changing 2K, so you are getting 10, right? So without changing 1K, 1K itself, I will get 10 volt as the output. 2 times amplification will be done. How to amplify, how to make that we will see. Here you can see one thing called duplicate mode, that whatever you want to duplicate, you can duplicate here. Okay, if you click on that means you will be able to duplicate. So I am taking the operational amplifier here, view and click zoom to fit, and then same hierarchy I am putting. So here, okay, so this also I require, and remaining things are not required. Okay, that is the major advantage. Don't think that again we have to repeat every circuit, and that's why I didn't copy everything. Understandable. So what I am telling, I am taking only ground points for my understanding. So this one and one more ground point is just a duplication of a partial portion. Okay, now I am going to connect everything. So positive feedback means non-inverting terminal operation means what? Means you have to ground this inverting terminal. That is what is the meaning. This is not perfectly connected, so you need to delete this. Okay, so I will delete this portion. Once again I will see here one clips is coming, right? Right. Now what I am doing is I am just connecting these two nodes here to here. Right. Next, I am connecting the same points from here to here. Okay. And then connecting from here, automatically it will come. It's very user-friendly software. You can do here. Okay. Anything. Right. Now you have to just connect this point to ground. Okay. So what I am doing is I am just taking a wire, taking one point and then connecting that to a ground. Now what I am doing is our work is over. This this is unnecessary. I will delete this. Okay, so right. So now I need to give biasing points. So biasing point is very simple. How to give biasing point? You can duplicate this and just keep here. Fine. And then this you duplicate this and you keep. How shortly the circuit is built, you can see here. That is the advantage. This VI, same thing you connect here. That's it. My non-inverting is ready now. I am applying input to the positive terminal, and non-inverting terminal is grounded. That is called as non-inverting input. Now this is more or less like a positive feedback. Okay, so from here it is going here and we are grounding. So if you take a positive feedback, means this is more or less this terminal and this terminal are equal. So what are all the connection we are doing here, same thing will be repeated here. So this is positive. Okay, so only one thing, what is the major changes here? The gain formula is 1 plus Rf by Ri. So what I am doing, only I am changing this resistance to back to 1K. Now you can check out what will be the result. So what will be the result? 1 plus Rf is 1K, Ri is also 1K. So what will happen? 1 plus 1 divided by 1 into same input voltage 5. So what you will get? 1 plus 1 is 2. 2 into 5 is 10. Here, without changing the resistance value, I am getting 2 times of amplification. So how to check this circuit? Let us check. Okay, you can see number of things are coming here. We will choose only whatever we need. Okay, so I want Vi 5 volts. I want output from this operational amplifier 10 volts. I want output from this operational amplifier. You can see two outputs here. This is your actual input. First, the output is starting and going from minus terminal onwards, right? So that is, if you want, means I will close this and I will run this once again. Okay, now you can see what we are going to do. First, I want the input voltage 0, 5 volt going on, up plus 5 to minus 5 it is going. Now I want to go with non-inverting mode. If I go with non-inverting mode, what happen? Input voltage is oscillating between plus 5 and minus 5. This voltage node 4 is the non-inverting mode. You can see here same thing. This 5 volt is amplified to 10. So and it is going to minus 10. But if I measure the voltage here, node 2, this is node 1 Vi, this is node 2. That node 2 is red color. You can see here initially it is going towards negative. So that means phase shifting is occurring. Okay. Now 2K, due to 2K and 1K, this become minus 10 and plus 10 like that. So, but without changing any resistance value, directly I am getting 2 times amplification in the non-inverting. If I want to realize open loop also, it is possible. How to realize? Very simple, right? So let us realize that also. So I will take this as a thing, and one more duplication I will do here. Okay, so same operational amplifier I will fix here. Okay, now view, zoom to fit. Now what I am doing, directly I am connecting without any feedback. I am directly shorting the terminals. That is the open loop operation. Open loop operation is nothing but what? We can ground anything and you can give input to either plus volt or minus volt. Whatever you want, you can give. No resistance. Directly you give the input. So what I am doing is I am duplicating this once again. This Vi I am connecting here. My work is over, and this is directly connected to ground point. Okay, so this point I am connecting it to ground here. This point I am connecting it to ground. Once again I will take the wire and connect this thing and this thing. See how the circuit is we are building without any confusion. We are building the circuit, right? So if you want to delete, means simply delete this. Now okay, now as per the wire you can just short this to snip. That's fine. After this, okay, it will go and beyond our control, means just click zoom to fit. Then duplication is nothing but what? This VC I am taking and I am giving here, and minus VCC I am taking and I am fixing here. So this is not done. Okay. So operational amplifier is deleted. Once again, I will duplicate and I will repeat. Sorry for the confusion. Second. So deletion means I will do this deletion. Everything minus VCC. Minus VI only I will connect here, right? Minus VI I will connect here. Okay, I will delete all of this. So I am taking the wire and connecting this terminal to negative. Okay, I need to bend, so I am bending and connecting. Fine. After that, this VI to be duplicated and connected here. So VI I am connecting here, and VCC, okay, I am connecting to this point. Minus VCC, carefully connect to this point. That's our work is go. Now we need to realize what is happening. Same thing, but what is happening means if I run this circuit, you can see here what are all the things. So now I want this voltage, fine, and this voltage already discussed, and this voltage, okay, and finally here I am unable to measure the voltage. Why? That means there is no wire arrangement. So what you have to do is just take one wire and leave it free. So after that you can measure whatever you want. Now once again I want this circuit, okay, I want this output, fine, I want this output, one minute, I want this output connected, I want this. You can see here what is the difference in the open loop mode. It is not giving oscillations, it is going directly. I am giving 5 volt here, but irrespective of my voltage, it is directly going into saturation. It is uncontrollable. But where it is going to use, it is going to use for square wave generation without anything. If you use one operational amplifier, give some input voltage whatever you want, and if you measure the output, means definitely you will get one square wave with the biasing voltage clipping, the clipped biasing voltage. Simple square wave generator can be realized. Did you know this concept before? A open loop amplifier, if you connect with this whatever voltage you want, either 5 volt, 10 volt, whatever voltage, and if you give some biasing voltage, means what happen? It will give you a square wave direct, square wave generator. But this square wave is uncontrollable. That is the only biasing voltage. 15 volt means directly it will give 15. I want to reduce this voltage to 5 volt, 10 volt or 9 volt means it is not possible. This is uncontrolled operation. This is how you need to, this is how much time you can see this circuit, how you, is there any cross wires or any complications in building the circuit? That is the main aim for developing this course. So this course, this circuits you can make use in your research articles or during writing your laboratory records. If you work out like this means no confusion will come. Directly it is selected. The graphs are high resolution graphs. Directly you can fit in your PPT points or any other graphs you can work out. So this is the major advantage of doing this topic. So hope you understand how to realize a simple circuit by using this LT Spice. Today we have taken inverting and non-inverting amplifier, and we have discussed what are all the how the amplifiers are working for different scenarios. Whenever it is going beyond the saturation limit, what happen? When it is within, how the estimated outputs we are getting, and operational amplifier is operating in open loop mode is what is happening. Everything we have discussed in this video lecture, and in the upcoming sessions we will take one particular circuit like comparator or anything, and we will go deep into that so that we can able to understand how that particular operational amplifier is going to compare different voltages, and how we can able to more or less what the topic is covered here itself. Comparator will give you square wave only, already it is covered here, but meanwhile I will develop one comparator and show you how it is going to compare the voltage and how you will get the output, that I will discuss in the upcoming lecture sessions. So please subscribe the video, and you can able to watch the video continuously and gain the skills what I have did here, and practice yourself for more circuit and try to develop a open-ended circuit by yourself in your own design. Okay, this is the main aim. So I think we have come to the conclusion of this lecture. So anything means you can discuss, and thanks for watching my video. So keep watching, and best of luck for best of luck for your bright. Keep going and keep learning. That is what our ultimate aim. Thank you everyone. We will meet you in the further lectures. Okay, thank you.